This is the 6th video on second year integration techniques in A-level maths. The aim of this video is to go over a mixed set of integrals where the method isn't stated, and we'll go through determining the correct method to use and then solving the integral. So example 1. The integral from 0 to 1 of x root 1 plus x squared dx. Think about this integral as having two parts to it. Not to do integration by parts, but just to think about these bits individually. So the bit under the root, 1 plus x squared, and the bit outside the root, x. 1 plus x squared and x are related by differentiation. Which means it's very likely that substitution will be useful. So we will use substitution. The part that differentiates to something related to the other part, that should be u. So in this case, we would let u equal 1 plus x squared. Therefore du dx is equal to 2x. So we can assemble this. Don't write the limits, because we're changing the variable with which the integral is taken. So we're moving away from x and to u, and the limits are in terms of x. So like when x is 0 and x is 1, we're working in terms of u, or we will be working in terms of u. So we'll stop writing the limits. Write x, and then we've got root u, and if du dx is 2x, then dx is du over 2x, du over 2x, and x, top and bottom, cancel, leaving u to the power of 1/2, same as same as root u, du, and that becomes u to the power of 3 over 2 multiplied by 2 over 3 plus c. Well then, no plus c actually, because we've got limits. Then go back to reinstate x. So u is equal to 1 plus x squared. So you can write 2/3 1 plus x squared over 2, because the substitution was u equals 1 plus x squared. Then we can reinstate the x limits. So it's taken between 0 and 1. 2/3 1 plus 1 squared 3 over 2 minus 2/3 1 plus 0 to the power of 3 over 2. This leading term, 2/3, and then you've got a 2 inside the bracket, and it's square rooted and then raised to the power of 3. So times by 2 root 2 minus 2 root 3, and then 1 to the power of anything is just 1. You can factor out 2/3 from this, leaving 2 root 2 minus 1 as the answer. Okay, move on to a second example. Example 2. So integrating from 0 to 2, 5x plus 13 over x squared plus 6x plus 9 dx. Here the denominator, the bottom of the fraction, is factorizable. So this means we'll try partial fractions. So when the bottom is factorized, we get 5x plus 13 over x plus 3 squared. This can be expressed using partial fractions as a over x plus 3 plus b over x plus 3 squared. Multiplying both sides by x plus 3 squared leaves us with x plus 13 is equal to a x plus 3 plus b. Let x equal minus 3. So we get minus 15 plus 13 is equal to b. So b is equal to minus 2. There isn't another value of x that will zero out part of the equation like x minus 3 would. So we'll just let x equal 0. This gives 13 equals 3a plus b. b is minus 2, so 3a minus 2. 15 is 3a. Therefore a is equal to 5. So the original integral can be rewritten. So I'll write the original 5x plus 13 over x squared plus 6x plus 9 dx can be written as the integral, again from 0 to 2, of 5 over x plus 3 minus 2 over x plus 3 squared dx. This integral here can be separated across the minus sign. The reason for doing this will become apparent in a second. It's that the two parts of this, either side of the minus sign, are integrated by slightly different approaches. The part on the left here follows the k f dash x over fx pattern, and if you work through that carefully you'll get 5 ln x plus 3. The other part follows a u substitution pattern, a more general pattern. So we can let u equal x plus 3. So it follows this pattern because x plus 3 is a linear term with x just to the power of 1. When you differentiate this, you'll get a constant term, like the term at the top of this here. du dx is equal to 1, therefore du is equal to dx. Make those replacements. So 2 over u squared du. I'm no longer writing the limits here because this is quite confused now. Things are written in terms of u's and x's. It's not particularly sensible to put the limits in. I'm rewriting the leading part of this, then minus 2u to the minus 2 du, and then integrating. So we raise the power on u to minus 1. We divide by minus 1, which is where this extra minus came from. 2. So 5 ln x plus 3 plus 2. And u is equal to, you can see over here, x plus 3. So 2x plus 3 to the power of minus 1. Now that everything's back in terms of x, the limits of 0 and 2 can be reinstated. They just then need to be plugged in. 5 ln 5 plus 2, and the power of minus 1 just means this goes on to the bottom, so 2 over 5, and then subtract, evaluating this with 0, so 5 ln 3 plus 2 over 3. 5 ln 5 minus 5 ln 3 is 5 ln 5 over 3. 2/5 minus 2/3, put both of those over 15, so it's 6 minus 10 minus 4 over 10 is the answer there.